Okay, here we are. Made it to the next page of the notes, and what we're going to do on this page is just quickly give you a few things about the categories of real numbers, just to help you distinguish between the categories and what kinds of numbers go into each category. The first group that we're going to look at here is, of course, let me say this. We're talking about real numbers, all right? These are numbers that you guys deal with. The ones when you think of a number, right, you think of a real number. Definitely what you worked with in Algebra 1. Now, this year in Algebra 2, we are going to work with imaginary numbers. We're actually going to get to imaginary numbers in Chapter 4, and I have a little note about imaginary numbers actually on the next page of the notes. So I'll wait until there to talk about them. So we're just right now speaking about real numbers, which has the abbreviation R. Now, when it comes to the natural numbers, a great way to think of these, let me highlight it for you, is these are the counting numbers, right? So when you are counting objects, you're using the natural numbers. When you count objects, we do not start with object 0, we start with object 1, and we use all positive whole numbers going to infinity theoretically. Now, that means that 0 is not included in the natural numbers, all right? There is no 0, and remember the abbreviation for the natural numbers is n. All right, so natural numbers is n. The next one on our list here is going to be the whole numbers, and there's just a tiny distinction between the natural numbers and the whole numbers, and the only difference is this right here. The whole numbers include the number 0. So it's the exact same set of numbers as the natural numbers. It's all positive whole numbers to infinity, but the whole numbers includes the number 0, and we give them the abbreviation W. That is the only difference between the natural and the whole numbers. The number 0 is included with the whole number group. Below that, we get to integers. Integers, real quick, I'll just put it here. The abbreviation for integers is Z. And what we're going to do with integers is we're going to now add negative whole numbers. So this is going to be, includes the negative value of each of the natural numbers. All right, so just the negative values of each of the natural numbers are now included in this category of real numbers. Now let me slide my sheet up here. Should be on the same page of your notes for you guys. Rational and irrational numbers. Here's the difference between these guys. First, let me give you the abbreviations. The rational numbers were Q. I apologize. Rational numbers were given the abbreviation Q. Irrational numbers were given the abbreviation I. And here's the difference. Rational numbers can be written as a fraction with a numerator and a denominator. Any number that you can write as a fraction is going to be a rational number. When you're able to write a number as a fraction, what that means is it means that it is a terminating decimal or a non-repeating decimal. So there are definitely, there are decimals that are rational numbers because they're numbers that can be written as fractions, as opposed to irrational numbers, which are numbers that cannot be written as a fraction. What that means is that irrational numbers are numbers that are non-repeating decimals. They don't have a sequence of numbers that repeats. They don't come to an end. They're not a finite number. Theoretically, irrational numbers go on to infinity, decimal places that go to infinity. Let me give you a couple of examples of irrational numbers. Maybe it'll make it a little bit more concrete for you in your mind if you think of these specific examples. The first one would be the number pi. Pi is an irrational number, it is a non-repeating decimal. It cannot be written as a fraction. We round pi to 3.14 to make it a little easier to remember. Your calculator, as I mentioned in the last set of videos, has a pi button on it. I believe your calculator actually goes out to 8 or 9 decimal places, but still, your calculator is going to be rounding pi off. Theoretically, pi is a number that continues to infinity, an infinite number of decimal places. Another one that is an irrational number we'll actually get to later on in the year. We have an entire chapter in which we will work with logarithms. And one of the bases for these logarithms is going to be the number e, which I know seems really weird that we're calling a number based on a letter. That's just what we call it. We call it the natural base e, and it is an irrational number. So this is the natural base of a logarithm. Again, don't have to worry about it right now what that number is. We'll get to that later on in a chapter, but you actually do have a button on your graphing calculator that represents this natural base e for logarithms. It's an irrational number. It is a non-repeating decimal that has an infinite number of decimal places. That takes care of everything on this page of the notes. Flip on over to the next page. We'll talk about imaginary numbers and a few other things. I'll see you there.